There was a refrigerant sitting in your walls 50 years ago that needed no power plant, no spinning motor, and no monthly bill to keep running. And almost nobody alive today has ever felt its cold. Most people assume refrigeration has always meant electricity, a compressor, and a meter ticking away outside the house. That assumption is wrong, and the real story is stranger, older, and far more political than physics class ever taught you. Welcome to Next Reveal, the channel where we dig up the science and technology that quietly vanished from everyday life. Not because it failed, but because someone decided it couldn't be sold the way they wanted. Today, we're looking at ammonia cooling, the system that once chilled homes with nothing but heat, and asking the uncomfortable question, why did we really walk away from it? To understand what was lost, you have to understand what people believe cooling requires. Most assume cold only comes from a machine that uses electricity to squeeze a gas into a liquid and back again. That's the modern compressor cycle, and it's everywhere, in your fridge, your air conditioner, your car. But that's only one way to move heat, and it isn't even the oldest. The actual principle is simpler than people expect. When a liquid evaporates, it absorbs energy from its surroundings to make that change of state happen. That's the entire secret behind every form of evaporative cooling, including ammonia-based systems. Ammonia happens to be exceptional at this. It evaporates at a very low temperature relative to ordinary conditions, which means it pulls a large amount of heat out of anything nearby when it transitions from liquid to gas. That single property made it one of the most prized refrigerants in industrial history, and it still is. Here's where things become interesting. Absorption refrigeration, the kind that used ammonia, didn't need an electric motor to move that gas through its cycle. Instead, it used heat itself, often from a simple flame, to drive the chemical process. A second substance, typically water, would absorb the ammonia gas after it had done its cooling work. Applying heat would then drive the ammonia back out so it could condense and start over. Heat in, cold out, with no moving parts to wear down. That's the entire engineering miracle in one sentence. This wasn't theoretical. Absorption cooling technology using ammonia was developed and refined through the 19th century, with engineers building working ice-making machines well before electrical grids existed in most of the world. By the early 20th century, manufacturers had shrunk and refined the concept enough to sell small absorption units for ordinary households, especially in places where power lines hadn't yet arrived. These devices ran on kerosene, on gas burners, sometimes on nothing more than a wood stove's residual heat. But that's only part of the story. The deeper question is why a technology this elegant, this durable, eventually disappeared almost entirely from residential use while staying firmly entrenched in industrial settings. The answer isn't really about performance. In the early 20th century, a wave of new synthetic refrigerants emerged. Chemically engineered, patentable, and marketed as safer alternatives to the toxic gases used in some early compressor refrigerators. These synthetic chemicals could be owned, licensed, and sold exclusively by the companies that manufactured them. Ammonia, by contrast, is a naturally occurring compound. Nobody invented it, so nobody could lock down exclusive rights to sell it as a refrigerant. That distinction mattered enormously to an industry trying to build long-term, repeatable revenue. What happened next changed everything. As synthetic refrigerants gained traction, manufacturers built business models around equipment that required ongoing electrical consumption, proprietary chemicals, and periodic replacement. Compressor-driven refrigerators became the dominant household standard, especially as rural electrification programs extended power lines across farms and towns throughout the early and middle 20th century. Once electricity reached nearly every home, the core advantage of heat-driven absorption cooling, namely that it required no electrical grid at all, stopped mattering to most consumers. This is where the story takes an unexpected turn. Some of the most significant scientific minds of the era took absorption refrigeration seriously, not as a curiosity, but as a safer future for home cooling. Concerns about toxic refrigerant leaks in early electric refrigerators led to genuine research interest in sealed, heat-driven alternatives with fewer mechanical failure points. Patents were filed during this period for ammonia-based absorption refrigerators specifically designed to minimize moving parts and leak risk. That historical detail alone should make you pause. Brilliant scientific minds saw absorption cooling as the safer, more elegant long-term solution, yet the market moved in a different direction entirely. If you're enjoying this kind of deep dive into the technology history we were never taught, this is exactly what Next Reveal does every week, so consider subscribing if you want more of these hidden stories surfaced properly. So why does ammonia still dominate certain corners of refrigeration today? Walk into any large-scale cold storage warehouse, ice rink, brewery, or major food processing facility, and there's a strong chance ammonia is the refrigerant doing the heavy lifting. Industrial engineers have never abandoned it because, pound for pound, ammonia remains one of the most thermodynamically efficient refrigerants available. It moves heat exceptionally well. That efficiency never went away. What changed was simply where the technology was allowed to live. in massive regulated industrial systems with trained technicians, rather than in your kitchen. And here's the genuinely ironic twist. The synthetic refrigerants that displaced ammonia in homes turned out to have a devastating environmental cost. Chlorofluorocarbons, the chemical family that became dominant through much of the 20th century, were later found to be destroying the ozone layer. International agreements eventually forced their phase out. Ammonia, meanwhile, has essentially zero ozone depletion potential and negligible global warming impact. The old, outdated refrigerant turned out to be one of the cleanest options all along. So why can't you just go buy an ammonia cooling unit for your living room today? Here's the honest, necessary caveat. Ammonia is genuinely hazardous in concentrated form. It's toxic to inhale at high concentrations, corrosive to eyes and lungs, and under the wrong conditions, flammable. Industrial ammonia systems remain safe because they're engineered, sealed, monitored, and maintained by trained professionals working under strict safety codes. Older small-scale home units required care and respect that wasn't always given. This isn't a build-it-yourself weekend project, and any responsible discussion of ammonia cooling has to say that plainly. If you want heat-driven, low-power cooling for an off-grid setting today, certified modern gas absorption refrigerators, the type used in recreational vehicles and remote cabins, exist, are professionally engineered, and meet current safety standards. What does this story really teach us? It's tempting to frame it as some inventory of progress, where better technology simply replaced worse technology. But the actual pattern is more nuanced. A naturally occurring, highly efficient, environmentally benign refrigerant was sidelined from everyday homes largely because it didn't fit a business model built on proprietary chemicals and electrical dependency. The industrial world never stopped trusting ammonia. It just stopped being the thing ordinary households were sold. That's worth remembering. The next time you hear someone insist that whatever technology dominates the market today must be the objectively superior choice. Sometimes the better idea is still out there, quietly doing its job in a warehouse you'll never see, waiting for the right moment to be remembered. If this kind of forgotten engineering history is something you want more of, subscribe to Next Reveal, because we're only just getting started uncovering the technologies that got left behind, not because they failed, but because nobody could figure out how to bill you for them every month,